You are staring through lab glass at an 8-step puzzle. Instead of guessing, a raven solves it in just 24 seconds. Surviving icy tundras requires serious hardware. This avian predator packs a brain-to-body ratio that actually rivals a chimpanzee. To reach the hidden meat, the bird confidently pulled strings, dropped stones, and nudged levers with zero previous training. Executing that level of abstract reasoning in under half a minute is equivalent to a human toddler doing multivariable calculus. Their visual cortex processes reality at 80 frames per second. They calculate physical trajectories twice as fast as you can. Deep inside the skull, a specialized region called the nido-pallium fronto-palliali acts as a massive command center for sequential planning. That hardware is expensive. This brain drains 20% of the bird's daily metabolic energy, despite being physically tiny. Navigating frozen peaks at 6,300 meters, ravens run complex spatial geometry while enduring -40-degree winds. Their working memory effortlessly holds 7 distinct physical variables at once, perfectly matching the mental capacity of a human adult. Nerve impulses whip across these circuits at 60 meters per second, allowing split-second tactical audibles when a puzzle piece sticks. Wait, actually, they even plan for tomorrow. In 2017, Cambridge researchers proved ravens stockpile specific tools 17 hours before needing them. They manage this because avian forebrains cram 120,000 neurons into every milligram of tissue, totally eclipsing human cortex density. Beak sensors detect microscopic latch vibrations. But how do they integrate that touch data without a mammal's cerebral cortex? Beating this box demands 4 distinct mental tools: causal reasoning, object permanence, impulse control, and sheer unhinged spatial rotation. Packing over 1 billion densely concentrated neurons into a miniature skull gives the raven processing power equal to primates. Subscribe. Without a layered cerebral cortex, the hyperpallium coordinates complex cognitive operations using 14 distinct visual and sensory processing modules. A strict 1-to-1 ratio of support glia to active neurons allows lightning-fast computations without massive structural bulk. Synaptic connectivity reaches 800 million connections per cubic millimeter, packing triple the network capacity of a mammalian brain. Tiny gaps between dendritic spines measure just 0.4 micrometers, cutting chemical signal transmission delays down to 0.2 milliseconds. Imagine your brain shrinking to walnut size while retaining full tactical intelligence. This neural compression defines corvid mental architecture. Myelinated axon fibers transmit motor decisions at 120 meters per second, creating near-instantaneous physical feedback loops during lockpicking. Concentrated D1 dopamine receptors boost task persistence by 45% when attempting complex multi-step physical sequence challenges. Subscribe if you believe intelligence takes many surprising evolutionary paths. This avian neuroarchitecture bypasses millions of years of mammalian evolution. During intense logical focus, raven brain tissue consumes 1.8 micromoles of glucose per gram every minute to maintain focus. At Lund University in Sweden, researchers documented ravens choosing correct tools with 90% accuracy before touching any apparatus. Direct neural pathways from 15 million arcopallium motor neurons allow surgical beak control when manipulating delicate wooden latch mechanisms. Information bridges between left and right brain hemispheres in 1.5 milliseconds, enabling synchronized visual processing across both eyes simultaneously. Sensory integration across visual and tactile channels completes in 12 milliseconds, forming immediate spatial maps of complex puzzle boxes. Peer into the eyes of a wild raven atop a mountain ridge, calculating aerodynamic angles and puzzle forces simultaneously. By suppressing the instinct to grab immediate food, a raven easily waits 15 minutes for better rewards. Neural breaks hit in 8 milliseconds. That's faster than you can close a laptop when someone walks in. Wait, actually, it gets weirder. Ravens select tools 17 hours before using them. In bartering tests, 86% rejected cheap bread to trade for sausage later. Brain scans from Cambridge University show them mentally replaying choices beforehand. How do they outsmart toddlers? When faced with new puzzles, they pause for 14 seconds to calculate mechanics. A toddler fails delay tests that adult ravens pass with 94% accuracy. They even hold grudges against lying researchers for 4 years. Unhinged behavior, honestly. Crafting hooks requires 3 precise bending steps, using just a beak. From the Alaskan Arctic to scorching deserts, their logic adapts anywhere. Your prefrontal cortex packs 25 billion neurons, yet ravens match your logic with barely 300 million. Absurd efficiency. In multi-stage tests, 4 out of 5 wild ravens solve complex knots on their first try. Ever since 1943, researchers have tried breaking their logic models. As biologist Bernd Heinrich noted, they run full mental simulations before moving a single feather. Separated from mammals by 300 million years, the raven proves complex intellect evolved twice. While mammalian neocortex structures expanded over 150 million years, birds pack neurons 6 times tighter inside a tiny skull. Think your brain is efficient? A raven head weighing 15 grams matches primate problem solving. Their territorial calls hit 100 decibels across forests, while an encephalization quotient of 1.3 leaves average pets in the dust. Vocal mimicry hits 85% acoustic precision, making them feathered copycats. Researchers at University of Vienna watched one bird slide down a snowy roof 12 times in a row, purely for entertainment. They nest on Mount Everest at 6,300 meters without freezing solid. How do young birds learn these trick plays? Cultural transmission hands down tool mechanics across 10 generations. In 2023, robotics teams started modeling autonomous flight systems directly on raven decision trees. Pass a mirror test, Corvids smash self-recognition tests with an 80% success rate. Surviving up to 69 years in captivity, their logical sharpness never fades. Running on 2 watts, this bird solves multi-step puzzles using less power than a nightlight bulb.